Aqualia is a global water operator, so we are merged and part of the FCC group. We are a huge construction group, and Aqualia is specialized in the water cycle. So we deal with everything related to water, either drinking water, facilities, networks, and wastewater treatment, of course. In my case, I belong to the innovation department, so we are developing new products. Fully, your Sentry probes help us a lot in this purchase of new technologies and improvements of the already existing assets.
We met Jose a few years ago, and we started a conversation about an industrial client that Aqualia were dealing with. That's obviously slightly different to what Roberto was doing with a municipal client, but a good contrast, I think, here. They were piloting an anaerobic sequence batch reactor. Do you want to tell us a little bit about that batch reactor and what they were doing, Jose?
Of course. So yes, in my region, so we are working, and I'm based in Galicia, which is the northwest region of Spain, and there everything related to food, and especially to seafood and fish is very powerful. So in this case, we are talking about a processing entity which has a huge revenue and one of the most important players in fish canning worldwide. They need to improve their wastewater treatment, and in our case, we love anaerobic processes because aerobic processes consume a lot of oxygen. We have COD that might be converted into bioenergy. We wanted to test with them, and the good thing with industrial clients is that normally you need to demonstrate your capabilities, and doing it at pilot scale helped us to get information about their influence, because you know that industrial sector is evolving all the time, and you might find surprises and new things with influence. So we had the chance to test the influence, and the good thing about the Sentry probe is that we got real-time information about what was happening real-time in the facility, because as Roberto was mentioning, sometimes even in municipal sector, which is very stable, you get surprises and sometimes inhibitions. Imagine in the industrial sector, where sometimes they don't have a clue about what's happening into the facility, and you have to treat the water. Sometimes you arrive there at Monday morning and the biology is dead because no one knows why something happened and something arrived to the wastewater treatment plant. Having the signal in real time, we had two probes, one at influent and one inside the anaerobic reactor. And what is marvelous with this real-time information is that you know that SBR work on a time basis. The good thing about the Sentry probe is that we had the chance to know when inside the anaerobic reactor the organic matter was already removed, which was wonderful because then it allows us to, I would say, optimize the time of the cycle, so you don't have to set the time of your cycle just with a time base. You can use this real-time organic matter signal to really match your needs and improve a lot, and also meet the regulatory discharge limit. We had another challenge there, is that we had a very short amount of time to do our experiments. So here you can see, for example, how the signal evolves with the different phases of the anaerobic SBR reactor. So you have an increase within the feeding, and then once you stop the feeding, you reach a peak, and then the organic matter is removed by the bacteria, so the signal drops. And you know, when you see this difference and this plateau, it means that the organic matter has been totally removed. With the Sentry probe, we had the chance to know exactly when the organic matter was removed in the reactor. We also recognized some specific details related, for example, with these red regions. That was something we had with an internal recirculation that was somehow bringing some noise into our results. So even it helped during this pilot phase to really adjust the detailed engineering that we needed for the full-scale plant. Actually, I must admit that it brought us real-time information that we normally hadn't, because sometimes you get these toxic or toxic loads with normally some cleaning agents they add to the industrial wastewater. So we had the chance to discuss with the client and see how we can adjust the results. Here you can see, for example, a profile of the reactor when we hadn't these regular basis swinging in the signal. And this was mainly due to something happening beforehand the reactor. To summarize, we had somehow a high stress in terms of time for the piloting. We could analyze carefully. For example, here we can see the daily variations and also what was the effect of, for example, the weekend. Normally during the weekend, they perform the cleaning inside the facility. Then during the week, you have a more regular operation. All this variation, all this information was really crucial for us to build the detailed engineering project for the client. We are very happy to say that thanks to this information and thanks to the knowledge we got during this pilot phase with the client, we will probably be awarded with the APCB contract with them. All this digital tool brings important assets to really jump into the market, convince new customers, and for us to really make an accurate, detailed engineering and gain all the information, what's happening inside the biology, and especially crucial when you're talking about low-growing microorganisms such as anaerobic microorganisms.